So for this one, it says 4 and 1/5 times 1/3 minus 1 and 1/4. You can work it if you want, but I'm going to go through, so you're free to work it out. Again, we're going to deal with this part first and see whatever we get. And then after that, we're going to subtract. But what I normally ask you to do is change all your mixed numbers into improper fractions, right? Change them. So we're going to just change them. So 5 fours 20 plus 1, that's 21 over 5 times 1/3. And I'm just going to change this. 4 ones 4 plus 1, that's 5. So that's minus 5 over 4. We're going to work out this part. All right. Remember, when you multiply fractions, you don't need any LCM or anything. So LCM is just for adding and subtracting. So whenever you multiply, you could try to cancel anything at the top with things at the bottom first. If not, you just multiply across. All right. So here I could cancel because 3 into itself is 1. 3 into 21 gives 7. So basically, we could say 7 times 1, that's 7, over 5 times 1, that's 5 here. So the multiplication comes to 7/5. Then you're going to subtract 5/4. Now, because you're subtracting, all right, because you're subtracting, definitely you need LCM because your denominators are different. And this is when the LCM comes in, but you have to remember, what is the LCM for 5 and 4? It's 20. So 5 into the 20, that's going to give you 4 times. And then 4 times 7, that's 28. The 4 into the 20, that's 5 times. 5 times 5 on top will give you 25. And here you're going to subtract 28, subtract 25, you're going to get 3 over 20. 3 over 20 is the answer in its exact form. So they said here, give it in its exact form. These are fractions. You don't have to do anything else. Right there. I'm taking some questions. Are you okay? If not, I could re-explain something.
Sir.
Is there anybody who's not okay?
Sir.
Go ahead, I'm listening to you.
Sir, do you have to cancel the 21 over 5 to make it smaller?
No, you don't have to, but it's better for you.
Sir, what if I didn't cancel it and I got an answer? Would I still get it correct?
You're correct. As I said to you, you don't have to, it's better because you're gonna get bigger numbers to work with.
Oh.
So that's why I said it's better, because I'm positive you're gonna work with 21 over 15 minus 5 over 4, right?
Yes, sir.
And this is just a small case. In other case, it's going to be 500 or something over a big number. So sometimes we might say to you, look, if you can cancel, the reason why I cancel, it's better because the numbers you're going to work with in the end is smaller. Also, so it's okay. But I'm just telling you, like when I work like this, I'm just saying, if you can. You notice I said if, all right? So if not, the answer would be okay. But if they say in the lowest form for the answer, you'll be wrong.
Sir, one question. With your cross multiply with the 7 over 5 and the 5 over 4 here. So why not
No, I didn't. And I didn't cross multiply. You saw it as cross multiplication. I did a regular fraction where I divide the denominator into the LCM and multiply by what is on top. It's going to appear like cross multiplication because you know about that. It appears because you know about it.
Oh, because trust to the 5 here, so and then
no, but I did
5.
say, 5 into 20. I did say, see the arrow there, 5 into 20 4 times, and I put the 4 here. That's how we do fractions. And we say 4 in, yeah. So you can cross multiply if you want. if you
Okay.
want.
But I guess the fraction is better. You multiply the bottom, the two denominators, and then to see how much you'll get out of that. All right, thanks.
It's very conditional to the numbers you're doing. And that thing that you just said, remember, cross multiplication only work for adding and subtracting, nothing else.
Yes, sir.
But there are a bunch of things that can work. Bottom line, if you don't get this as the answer, you might get a multiplicative version like 6 over 40 or 12 over 80 or stuff like that. But I'm just saying, answer, all right? So you have to look out. Anybody else? Terry, you get that or not? All right, let's take a look at this second question here. What you want to do when you have a question like this is you can work out the top part first, draw a line. So it's never a rush. You can find out what the top is. It's not about trying to rush off. You don't get marks for rushing off. So you could put like that. You need to find out what is on top and then you do. So you could do 3 layers of working. So you also could, if you want, you could find out what this is. So you could write back this. I'm just saying, not like you're going to get marks right, but I'm just saying in an effort to make sure you're good, you could write back this. Or you could put this on your calculator here and then get a number to go on top. It's up to you. There are various things that you can do. So if you put this on your calculator and do it properly is the word, you'll get a number to go on top. If not, what you want to do is write back that, find out what is 1.25 square. Find out what it is. So find out what is 1.25 times 1.25. All right, and you're gonna get 1.5625. And then you go one more time, just do it, because you're trying not to make a mistake. So it's gonna be 4.1, then you subtract 1.5625. That will give you some 2.5375. And then you just do your last thing now, because it's calculating.
7.5.
Yeah, whatever you get is correct. So you just put your last thing there and you work it. So the bottom line is you want to end up with this as your answer. Why am I taking this step? Trying to get you not to make errors. Like this, the more you relax when you're doing your thing, it's fine. And it's never a race in the exam. So that's the answer that you should get. Is there anybody else that got something else? Anybody that got something else? Are we good?
Good, sir.
All right. Typical question here. Typical question here.
A stadium currently has a seating capacity of 15,400 seats. Calculate the number of people in the stadium when 75% of the seats are occupied.
Can you find 75% of something? That's what we're asking you right here. So you multiply these, then you divide by 100. So you just write the answer after that. All right?
So, around 11,500.
11,550.
Yep. On. You move on. You move on. All right. Next question. So the stadium is to be renovated with a new seat capacity of that. After the renovation, what is the percentage increase? It's not a big deal. Percentage increase, you will not get those little formulas from CXC. They don't give those. So it's an increase in percentage. So percentage increase is to get your percentage or get that increase. So you put that increase that you get over the original thing because you had to increase from somewhere, which is natural. So a percentage increase or decrease only can be related to the beginning, what was in the beginning, original. So you put that, you multiply by 100 because as long as you're going to percentage, you multiply by 100. So it's the increase. So you're going to find the increase. So the increase is to take your 20,970, take away what it was. What it was 15,400. So whatever that change is, you put it back over your 15,400. So this is going to give you a fraction of what happened. Then you multiply by 100 when you're done. So basically that's that. When you subtract it, you probably get about 5,300. Confirm with me. 5,390. You're going to put back that over the original. So when you subtract 2790 minus 15,400, you get 5,390. And so you just calculate again at work. So you take a calculator out and you divide that. So whatever you get, you divide that by 15,400 times 100. You probably get about 30, 35%, somewhere there about.
Yes, sir.
All right, let me just stop there for a minute. Any question? Pierre, you good?
Yes, sir.
So remember, Pierre, no put no feelings on this thing, and nobody no care. You hear? So let's cut and go through in life. All right. Anybody with a question? Anybody? Anybody? Are these are okay? All right. All right. So this question right here now, work it out for yourself first. You don't need to write the question, but you need to work it out. So I'm giving you 2 minutes to work it out. A neon light flashes every 5. Well, flashes 5 times every 10 seconds. Okay. So 5 times every 10 seconds. Show that the light flashes that amount of times in one day. All right, let me see who can show that. Show. That means you're going to work it out, and then when you're done, you're going to get you're going to get 4,000. You're going to start with some stuff, and when you're done, the answer will be 4,200. Remember, now, my time, it's now 12:25. So by 12:20, little bit. All right. So for a question like this, it says a neon light flashes every 10 seconds. You want to think about that. Every 10 seconds. Every 10 seconds, it flashes 5 times. 5 times. So if you check it out, if you check out this, it's going to flash 1 time every every 2. All right. Every 2 seconds it flash one. So you see them say 5 in 10 seconds. You're supposed to can still say so that's 1 every 2. 1 every 2. So if I can find out how many seconds in a day, I can just break this down. So there are many ways to break it down. How many seconds in a day? Well, in a day consists of 24 hours. All right. And 24 hours actually has 60 minutes. And every minute has 60 seconds. So we are thinking about that. Every minute is 60 seconds. So if you should multiply up these, you should be all right. Think about it. Now you're like 24 hours. All right, let us see the amount of, so remember, this is one day, and you have 60 minutes in a day, 60 minutes in 1 hour. So if we say, okay, if you say 24 hours times 60, this is telling me how many minutes in the day. And then if I times that by 60, it's going to tell me how many seconds in 1 day. Very simply. So that's the amount of seconds in 1 day. Think about it. 24 hours, you multiply that by 60, it turns into minutes, and then you multiply those minutes by 60, you get seconds. So this is the amount of second in 1 day, right? This is the amount. I'm going to rewrite it for you. That's the amount of seconds. All right, in a day. You're going to take your 24, you times it by 60, then you times it by 60 again. So that's whatever that comes to. Anything it comes to, that's the amount of seconds you have in 1 day to play around with. So you're looking at the fact that you have 86,400 seconds in 1 day. Now, the question wants you to show that the light flashed this amount of times in a day. But remember now, we saw that it flashed once every 2 seconds. We took that 5 to 10 and said same thing as 1 to 2. So now we're saying that if you take, so the number of flashes now. So let's just go for the number. All we're going for now is just the number of flashes. So I'm going to rewrite this. 5 times, I'm just writing this for you. You don't have to do it for CXC. 5 times equal 10 seconds. I'm just saying. Therefore, 1 time, I'm just giving you this, will give us 2 seconds. So we're saying that 1 time every 2 seconds. So all you're going to do, so the number of flashes in 1 day is to take the amount of seconds that you have in 1 day. You divide it by 2 because every 2 seconds it flash. And it's going to tell you that it's going to flash 4, 3, 2, 0, 0. Just like that. This is me explaining to you. In the exam, the moment you reach yourself, you divide it by 2, you're gone. But like me, I talk to you now, I'm going to try to show you some little stuff. 5 times every 10 seconds, which means 1 time every 2 seconds. So if you know the total seconds and how many times it flash, or after how many seconds it flash, then you divide it and you're good. We're good right there. Are we there?
Yes, sir.
Question, anybody? Question, is it clear? Getting out the number of seconds in the day is very important. And then making the link in terms of the interval of flashes right here. You can just keep working your thing. It's up to you. It's up to you. All right. That's a typical number 1 that you just saw. Already you know that's how the number 1s come. But then sometimes they could put buying and selling, but you see percentage coming out, those sort of stuff, that number 1. So they have a lot of choices in terms of how they set the questions. But at the end of the day, it's going to look like that. All right, at the end of the day, it's going to look exactly like those. So this is a typical number 2. And number 2 is always algebra. Like there's nothing else that comes there.
You know, why can't I put the job on?
So Number 2 is always algebra. So factorization and those stuff come up, or variation, anything like that, solving a simultaneous come up here, or any little thing in algebra. Okay, so it says factorize the following completely. Now, there are 4 types of factorization. You run them through your brain to see which one this is. I normally say start at the simplest one first, which is the one that deals with highest common factor. So you could see the highest common factor here is just h. So h is the common thing here. You open your bracket, you're going to divide this piece by h, then you divide that piece by h. So when you divide this, you get 5h. When you divide this, you get minus 12g. And you're gone. Like, it's 1 mark, and that is why it's 1 mark. Don't overthink it. So this is the answer to the question. Because you, as I said to you, whenever you get anything to factorize, please look at the various types of factorization that you learn, right? There are 4 types. It's highest common factor factorization, or we learn about grouping, or the quadratic, which is the AC method. And lastly, it might be the difference of 2 squared. So you could see it's 1 mark. They expected you to get that 1 mark just like that. It's not a big deal. All right. All right. Now let's take a look at this question here. If you try to think of the highest common factor, there's none, because number 1 is always there. So outside of number 1, can we find the highest common factor? No. Then you're thinking it's not grouping, because grouping needs 4 things, and this is only 3. It's not the difference of 2 squares, because difference of 2 square is 2 square things. So here it's definitely the AC method, where you want to name your A, which is the coefficient or the number that is attached to the square, it's 2. And then your B is a number that is attached to the X, which is -1. And the C, which is the number without any letters attached to it, it's -6 right there. So here it is that we're dealing with that. Dealing with that sort of thing here. Now, remember though that the AC method is designed for you to find the AC first. And whenever you're going to factorize the AC, you're going to see the quadratic. See there? 2x squared, then x, then nothing, and no x. You have to look like that. If it doesn't look like that, you're going to be in problem, okay? So here it is, we find AC, which means you're going to multiply 2 times -6. So 2 times -6 gives you -12. And you're thinking, no, whenever you have an AC that is a negative number, the numbers that you find, one must be positive and one will be negative. Remember, that only works when AC is negative, and it is negative. What are the possible things that multiply to give 12? 12 times 1 give 12. 6 times 2 give 12.
3 and 4, sir.
4 times 2 give 12. So all of those, and then you are going to have to pick the one that works. So yes, somebody said 3 and 4. And then you're going to have to decide now which one must be negative, which one must be positive. Let the bigger one take any sign B has. So you can see B is negative. So that means the 4 will be the negative. The 3 will be positive. You're going to take these and you're going to attach to it the variable for the middle, which is x. So x is going to be on these as you use them to replace that x right here. So you're going to have 2x raised to the second minus 4x plus 3x minus 6. So now you took these and you put them there. Now you have 4 terms. When you factorize 4 terms is when you group them. So in the middle of the AC method comes factorization by grouping. So you group them. So what is the common factor for this, then this, right? So the common factor for the first pair is 2 with x together. That means you're going to divide this by 2x. You're going to divide this by 2x. That's what it means. So 2x into 2x to the second, you're left with x. And then 2x into -4x, you're left with -2. So here it is that you finish group 1. When you go to group 2, remember that your brackets must look the same. So when you find your common factor, you're still thinking of what the bracket will look like. For example, we know it's going to be positive 3 that could go into the 3x and into the negative 6. So you open your parentheses, but you're going to divide. You're going to divide by it. So you're going to say 3x divided by 3, you're left with x. Negative 6 divided by 3, you're left with negative 2. And then so you could see that the brackets come back. If it didn't come back, then you know that you made a mistake or it can't work. Understand? So here it is that it came back. And when it comes back, we are going to just take one of these brackets. Take one. Because they're the same thing. And you see the other two things that are on the outside, they're just going to go here. Like, it doesn't get any harder than that. That's it. All right? And it doesn't matter which one you put at the front. So if you did it and you want to put this at the front, it's the same thing.
So I was going to ask you that.
Yeah, people always ask. It doesn't matter. Multiplication, right? So you're good to go. So I'm trying to go slowly. Slowly, I'm not even pushing. I'm just lazily going through right now. Question, anybody? Question? Always ask a question, right? Always ask a question. Always ask a question. Let's go. Anybody? We're good? Anybody who's uncertain, you want to ask a question regarding something, it's okay. We'll look at it. All right.
Sir, you said 4 different type of algebra.
Factorize is 4.
Sir.
We just did 2 types right now. Matter of fact, we did 3. You see, when I said 4, you might think it's some big things, but the first one was done here. So let me show you what I mean. Right now, you did 3.
Yes, sir.
You did 3 right here, because when you pull out this, that's the first layer of factorization to see something that is common. Yeah, and when we did the 4 term right here, that's a second. That's grouping. So and we were doing AC in the beginning. So when you do AC, you do 3 already. You know, that's what I'm saying. So I don't want people to overthink, because the moment you can identify something that is common, that's the highest that you're doing.
Okay.
The moment you see 4 terms and you group them up for work with them, then you're doing grouping, because grouping is just to group them up and to make sure that something is common for each group. Nothing else is there for grouping. You understand what I mean? So it's like factorization is set up in such that you'll execute 3 not knowing that you're doing it. Especially when you do the AC method, you do all 3 doing the AC method. So the only one that you wouldn't do is the special one, which is the easiest one. You identify the difference of 2 squared, and you will see it. You will see that one. Yeah.
Yes, sir.
All right. So here it is that they ask us to solve this equation. Whenever you're solving an equation, if you see brackets, you want to get rid of it. So we want to get rid of the bracket. So I'm going to distribute the 3 inside. And when you distribute, distribution is multiplication. So it's going to be 3 times r, you get 3r. It's going to be 3 times negative 15, negative 5, you'll get negative 15 here. And then remember now that when you solve, it's your duty to collect the variable on one side. So you're trying to isolate the variable. So you want to isolate the variable, and that's what you're about. So you just do it. In isolating the variable, you decide what side of the equation. The equal sign is down the middle. You decide if you want to collect them on the left or the right. It does not matter. So I am going to collect my variable on the left. That means I need this one over here. So how do I move something mathematically? I go the opposite to what it is. So it's a positive 3r, I subtract 3r, and I balance by subtracting 3r. If I should rewrite this just to relax, then I'll say r minus 3r, this is minus 2r. There's a plus 3 there. This is gone, and then I'll have negative 15 over here. Then I need to get the positive 3 over here. That means it's positive. I subtract 3. I subtract 3. Then I rewrite. Negative 2r is equal to negative 18. Don't make a mistake with these. You put these on your calculator, minus 1, 5, minus 3. It will tell you that is the answer. Okay? And then you divide both sides by negative 2. So as you could see, r is 9. So r is 9, not a big deal. So negative 18 divided by negative 2. And even these, I put them on my calculator. Negative 18 divide negative 2. And I look, it's going to give me. All right. So even when I know the answer, I still put it on the calculator for verification. So I know it, but it's just for me to make sure, because when you're making an error, your brain does not recall. So it's not like your brain will say you are making the error. You are going to think you're okay. But what the calculator does for you is 1 plus 1 is 2. And we put it on it, same way, and then we check. So that's regular solving. That comes at number 2 as well. Transposition may come. And I said may, they're up to them if they want to send it or not. They have option, but it's some algebra thing comes here. Meaning basic algebra.
Sir, can you carry it back down a little bit, sir?
So it's basic algebra that comes
Yes,
at
sir.
number 2. Yes, sir. Yeah, go ahead, Tina.
Sir, I didn't see how you get the 15, to be honest.
3 times negative 5. Remember, we get rid of the bracket. Remember, the bracket was there, and there's no bracket. And there wasn't a 3r either. There was a 3 outside the bracket, but when we multiply, it becomes 3r, right?
Sir, you did see what was in the back.
Yeah, man, because look, there is no 3r. There is no 3r. When the 3 multiplied by the r, that's how we get 3r. And when the 3 multiplied by the negative 5, that's how we get negative 15 for the next layer, right?
You can move it now, sir, when you're finished.
All right. Now, the C part to this, and it says make K the subject of the formula. Making K the subject is to isolate K, because to isolate, so you want to isolate K. It means solve for K. It's the same thing as solve for K. If you notice, whenever you're solving, you're isolating the thing that you want. It's the same principle. First thing I'll do, I'll get rid of this. So I'm getting rid of the things that are on the same side with the thing that I want. But they are farther away from it, but they're on the same side. So I'm not going to touch the pi because it is pasted onto the K. So I'll leave that for last. But definitely the positive 3t has to go. So opposite. So you got to subtract it. And the thing is, whichever side my variable on, I'm going to leave it there. So I'm not caught up in terms of I need to get it on the left. I don't care. So if I see the variable on the right side here, that's where it's going to stay. That's what I mean. So I'm going to have 2a on the left with a minus 3t. And this is equal to the pi symbol here with k squared. Then, now you want to split these off each other, right? So you're looking at the pi with the k to the second. And you ask yourself, what is the pi doing? If you don't see a minus in between or a plus or a division, it means it's multiplying. And then to go opposite to multiplication, you divide. So you had to divide that by pi and balance the equation by dividing it by the same. Remember, you learn whatever you do on one side, you do the exact thing on the other side. So this comes here. So you could see that the pi's would cancel. What you really have is 2a minus 3t. And this is all over the pi symbol. This is equal to k squared. And then from here, you will take the square root, because square root is what cancels square. Square root is what cancels square. So I'm going to put the answer here. The answer is that you'll have a big old square root. You'll have 2a minus 3t over pi. This is equal to k. That's what they ask you to do. And be careful with your square root. Don't do this. If you do this, you're wrong. If you have this, this is wrong. You notice my square root right now covers everything because that's what it did. It's not just for the top. Right now, it's for everything. So you have to look out and be careful. If you want to drop a comment,
Where does the square root come from?
Square root is the only thing that can get rid of a square. So why aren't you asking me where does the square go? You don't see the square on the K?
Oh, sir, I didn't see it.
Yeah, man. So square root is the only thing that cancels a square. And you have to wait until it is alone too. You don't do it with things attached to it. So if you notice, I wait until I had the K alone. And when I had K by itself, that's when this could cancel it. Then they cancel out each other at that time. Okay, so you just gotta take your time and you roll slowly and you'll get through. Anybody else with any other uncertainty? Going once, going twice. All right, so this question says, a farmer plants 2 crops, potatoes and corns, on 10 hectares of land, piece of land. The number of hectares of kind is C must be at least twice. Everybody read that for yourself. Come up with 2 inequalities. Like, I'm giving you 20 seconds to do that. 20 seconds for 2 inequalities. Quick and fast. 9, 8, 7. Remember, inequalities are simple. You'll get the argument. You'll get the cases, and you look at them. They'll tell you what represent what. So C is for corn, P is for potatoes. It says the farmer has 10 hectares of land. So right there, you're thinking that they said the farmer. Let me look. The potatoes. The number of hectares of corn and must be at least. Look at this. Must be at least twice the number of hectares of potato. All right. So corn must be at least twice. All right. So let's get to them. Corn must be at least. And when you say at least, you are greater or equal. This is what we just did in class. Greater, this is what we're doing tomorrow anyway. Greater than or at least equal to, where is it? Twice. Twice the potato. Done. That's one. Read this. A farmer plants 2 crops, potatoes and corn on 10 hectare piece of land. So a 10 hectare you have. All right. So I'm thinking, remember now, we can't go over 10 hectares. So guess what? You see, the land for corn plus the land for potato must be less than or at most equal to 10. Because we can't go 11. We can plant up 9 though. We can plant 8. We can plant 1. We can plant none. We dare not plant 12. We don't have that space. So I have to go less than or at most 10. Tell me if you get what I say. So in other words, in the planting up of the stuff, you can't use more than 10 hectares of land because at 10 you have. And they never told us anything to say that he has at least 10. No. We have to go at most 10 because we can't go over this. So those are the 2 inequalities. They normally give you 1 apiece. Not a big deal. Anybody want to query that? Are we good? 1 mark for this. 1 mark for this. You miss up something, you lose the mark. It's not a big deal. All right, we could go.
Wait, sir, could you go up a little bit, please? Okay, you can go ahead.
Sir, so
All
in
right.
this instance, it doesn't matter which one go first, right?
No.
Because to me, I
Like
think
which one?
number
When
two
you're
would have
saying that
been,
this one,
I think number two should have been number one, so that's why I ask you.
oh no, there's no number. I mean, just write number one. There's no
Oh,
number.
okay.
There's no number because you notice them say right one. Two
Yeah.
inequalities. Yeah.
Yeah, why am I asked? Because based on the reading, and so I was saying if it
Yeah,
doesn't
but
matter.
doesn't matter. Make sure you have these two. All right. The diagram below shows a hexagonal prism. Yeah, it's a prism because you see the twin face. See it here again. And the face the face is an 8-sided figure, so it's called a hexagonal prism. No big deal. They want us to put in some stuff like complete the following statement. The prism has dash, face, blah blah blah. Face, remember, face will be the broad surfaces. Like if you are rubbing on it. So the two hexagons would have been 2. I'm just saying. And then this is 3, 4. I'm talking about faces. 5, 6, 7, 8. So that's 8 faces. Talking about those broad faces. Faces. The surfaces that if you want to wipe it down, mainly that part you wipe. So we get 8. Edges now, if you claim, say, I draw this, I edge I draw. This is at 1 edge, 2 edge, 3 edge, 4 edge, 5 edge, 6 edge, 7 edge. You get me? So I'm just saying, the more edge, these are edges. When you say I draw, I edge I draw. All of these are edges. All of these are edges. So then you're counting up those lines. So I'm just saying, this is 1, 2, 3, 4, 5, 6 for the hexagon. For the hexagon, and then you have 6 more already drawn and stuff. So that's a dozen already. So that's a 12 if I'm just looking at the hexagons. 6-sided figure. 6 and 6, 12. And then now we're going to count the long pieces now. Just add them to it. 11, 12, no, 12, 13, 14, 15, 16, 17, 18. So this is 18 edges. Open and see what I go on. It's not a big deal. Not a big deal. A grade 6 math system I put in on the sun. And then now vertices will be the corner spots like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 vertices. And you're done. Everybody good?
Yes, sir.
A free marks them there, man. Free marks, grade 6 stuff. Yeah. Free marks. All right. Hold on. My paper. Wait. Look at this. All right. So function can come here and other things. So I'm gonna tell you, so this is not a function spot. Other things can come. Like if you just randomly go up and pass paper, you're going to say that number 4, you could get stuff like this or other stuff come here. All right. So you could check it out. So those are the things you look out for and try to prepare for. This is a compulsory section of the paper. So these ideas do come. So it says f of x is equal to 2x plus 7 over 5. You're finding f of 4, then you're finding f of negative 4, and the question wants you to add them. This is going to give you a value, that's going to give you another value, and you add them. So first, you're doing f of 4. This is the function. So you're going to substitute. I'm going to leave a bracket there. That's f of 4. For f of negative 4, you're substituting. What are you substituting? You're substituting what they ask you. 4, so you put 4 here. 4 2 is 8 plus 5. This is plus 7. This is 15 over 5. I believe I'll get 3. So f of 4 gives 3. For f of negative 4, put your negative 4 in there. Negative 8 plus 7, you could see. So this is actually negative 1 over 5. That's negative 1/5. Done. No decimal or anything. So when they ask you to say, all right, could you give us a value for this? F of 4 plus f of negative 4, you could just write the answer. You're adding 3. Well, it's actually subtracting now. So it's because this is a negative number, so it's 3 minus 1/5. Negative and minus, same thing. So if you know the answer, you could just write it, because if you have 3 things and you're taking out 1/5, you're left with 2 and 4/5. Like, don't overthink it. Imagine you have 3 cakes and you gave away 1/5. You're left with 2 and 4/5. Just like that. Are you good? Talk to me, I'll wait.
Sir.
I'm listening to you. Go ahead, speak.
Sir, you left me off right where you have negative 1 over 5.
Negative 1 over 5. Oh, negative 8 plus 7 is what?
Negative 1.
Okay, then that's it.
Oh, sir, you just put everything at the bottom where you have 4.
Wait. You good? You sure you're all right?
Yes, sir. Sir, I see.
All right. Good.
Sir, I'm kind of lost right here. I'm lost
man.
where you get, I know the tree, you care about the tree from, where you get from the first, the 4, and then the negative 1/5 equal. Oh, okay, you take away the,
It is. A negative is a takeaway from something.
okay. Okay,
That's
sir.
what, that's what I was saying. But if you want to work it the long way, I just never end in the mood for this. Because the
Okay,
long
sir.
way, I just said 3 over 1 minus 1 over 5. You draw
Okay,
your line, you put your LCM, and you say 5 into
okay,
that.
sir.
You understand?
Yes,
You
sir.
get-
Yes, sir.
I just never in the mood to go through this, guys.
All right,
Because
sir.
it's like a simple, I'm just saying 3 minus 1/5, you're left with 2 and 4/5
Yes,
of it.
yes, sir.
Let's be real, don't overthink it. We feel like
Okay, sir.
we skip out one question. Right? Yeah, ma, we skip out one question, you know. See ya. But anyways, we're gonna go back to that. Let me see. Wait. All right, let me just do this and then we'll go up. 'Cause we miss a part of a question, all right? We miss a transformation question, but we'll go back to it. All right, so it says calculate the value of. So it says calculate the value of x for f of x equal 9. So when they ask you to do this, it's not a big deal. They're asking you what number comes here so that the f function work out to give 9. So the f function that you had was 2x plus 7 over 5. And they're asking what number could come here such that when you put the number there and work out the math, you get 9. So whenever you get a problem like this, don't overthink it. You're going to set the f function to any number they claim you should get. They said you should get that. Set it to 9. So it's like you're saying right now, the f function equal 9. Can you tell me what this is? Which is a regular math you're doing. It's just that people see it and not think too much. Just don't think too much. We are asking you what number goes where x is, and when you max out everything, the answer becomes 9. So you're gonna solve for x. That's why them say calculate the value of x. In other words, solve the value of x that caused this to happen. So then, you're gonna multiply both sides by 5. When you do that on the left side, this will cancel itself, right? You will see the 5. That's why you did it. So the fraction is gone on the left. then you are left with 2x plus 7, which is equal to 45. Now, as you go through here, as you could see, we're going to subtract 7 from both sides because you're solving a regular equation. You're solving. So at every step of the way, you're applying back yourself, whatever you learn, you just go through. So this is equal to 38, right? And then you divide both sides by 2. It's telling you that x is 19. In other words, if you put 19 here and work it out, you will get 9. That's what they're saying. So in other words, then, if anybody remember, when we say function and relation, we are saying there is some function here. Let me tell you. I'm just using this to explain an idea to you, okay? That's your x values of which you have various numbers, right? The function between this is 2x plus 7 over 5. In other words, whatever x value you choose, it's going to be multiplied by 2, add 7, then divide by 5, and then it's going to give you the y values over here. That's what we are working on. All right? So we are suggesting here that 19 comes here, and when you mingle up in this, you push out 9. So 19 produce 9. That's what they're saying. That's what it means. That's what you're working out. What produced the 9? Okay? It's 19. So 19 produced 9. Anybody? Question? Question? Question right there?
Sir.
Talk to me. I'm listening, man. Me there, man. Talk, man. Me there right here.
Sir, this question lost me. I don't know if I look, me that look for the calculator, sir. Me just lost. Right,
Which one?
right,
Talk to me. Yeah.
right. Where you have the 2x plus 7 divided by over 5 equal 9 times 5. There's from there, so sir, I'm gone. I'm lost.
You're talking about solving the regular equation right here?
Yes, sir.
Yeah. So you are okay when we cancel this guy, we had to.
Yes, sir.
So we wrote back what's left. And that's what you're supposed to do in an exam. What's left? 2x plus 7 equal 45. Are you okay with this? Because that's what is left when you do it. That's what is left right there. Talk to me.
Yes, sir. Yes, sir.
So what would you do next? Because the objective is to isolate x. When you solve, is to isolate. So you're gonna get rid of the 7 right yourself by doing opposite to it. If it is adding, you subtract, and vice versa. It was adding, so we subtract. And whatever you do on one side, you have to do it to the next side of the equation. You subtract. You sure say your last? So when you do it now, 2x is left with 38. Because 45 minus 7 is 38. Remember, I solve, but look here. If me in the class, me don't want to write x, me don't write too much. So like when me reach here, so you know, through we in the class, me just go do it. That's so that is. So it's not like me I go rewrite it again and then divide for you to see it, say it left by itself. No, because me in the class, me just divide it. But this was there first, and then we talk about it. Then I did it. But me I go do it right there. So you get what I mean? So probably that's why you're probably the last. But in other words, you have to stay with me with what we are doing. Because if you go and come back, it remember say everything I go actually twist up in a one by if you move and come back. So yeah, man. Anyways, the next follow-up question says hence. So it says hence or otherwise determining the value of. I'm not gonna do this. All right, because I've already said to you, if you have x and you have y's, x produce y. So if 19 come in and they give 9, the inverse of the 9, look at the same 9 this. The inverse of the 9 means that you go back to the where it come from. That's what inverse means. It's like a rotate. So if 9 produce, If 19 produce 9, the inverse of 9 produce back 19. They produce each other. So the answer is 19. No work out. So nobody feel like this word working out. We're not going to work it out. So this is something you need to make you need to know. So if f of, one more time, if f of 19 give 9, that means the inverse of 9 give back 19. I'm going to make up one fake story now. If f of A gives B, that means the inverse of B take you back to A. We just are telling us something one is supposed to know. If you work out this, it will go longer than the whole of yourself for the 1 mark. Because you're going to have to work out inverse of the function. And when they don't work out inverse of the function, then they're going to put 9 in there to solve to get back 19 when a 1 mark. So I'm just telling you something where your teacher is supposed to tell you. Understand this. All right? Just understand that. So you make a note of that, and we're gone. So the answer is 19, and it's coming back from here. It's coming back from here. Remember them ask you about f of x, them tell us, say, boom, and you find out you are 19 causing. So in other words, then f of 19 give 9. So if them ask for the inverse of the 9 and 19, both of them are inverse of each other. So, anyways, 1 mark, easily, you write it down. Oh, let me go back to the question. We miss out a question. Right on top. Now the blank space, one question they did look like. Well, one question that is somewhere else. Oh, see it here. All right. All right, so the question say, let me minimize. So the question say, a quadrilateral PQRS and its image P prime, Q prime, R prime, S prime are shown, right? Okay. All right. So you're looking at that on your screen. So the question now, let me see what question there. It says write down the mathematical name. Okay, we did the question here now. In a class. It says write down the mathematical name for this. Anybody remember what name this is?
Trapezoid.
Trapezoid.
All right, good. Some people call it trapezoid.
Trapezium.
Some people call it trapezium. In America, they say trapezoid. Caribbean, we say trapezium. Same thing. All right, so we have that though. Now it says here, PQRS is mapped onto, remember we said when you see stuff like these, it means that is the image, okay? This is the image. This is not original. This is image, not the original thing, all right? So it was by an enlargement scale factor, K and the center. And they're asking for K and the center, AB, AB. We did a question like this already. Matter of fact, we did this same question. And I was saying to you that all you got to do is to do this. So I'm just going to do it again. All right. So if you have an object and its image, and your intention is to find the center, we realize it's an enlargement, we're told. All you have to do is to connect two corresponding pair of points, like Q correspond with Q prime, and R correspond with R prime. You only need to link two of them. So you don't have to go through the whole thing of linking R. You only need to link two of them. All right, two. So so I'm gonna draw a long line through it. Make sure that you draw the line at the right place. Relax. Make sure you say that touch the right spot, and you do that. All right, so you have that. That's 1. So you connect that Q to its Q prime, draw a long line through it, because you're not going to know when it's going to cross. And this is for enlargement only. There's nothing else like this. I'm not telling you that you're going to do this for every. This is for enlargement. You make sure, boom, you relax. And you draw up your thing, and you see where it crossed, right? All right. All right, so when you do it, when you do that, you're going to see the center. This is to identify the center. So you're going to realize that the lines are crossing here. So you take off the coordinates here for the center of this enlargement. The numbers were not there, so you look, this is -4, this is -5. You kind of make sure that you map out it to make sure you have it. So -4 means this is 2, this is 1. So -4 met 1. -4 meets 1 right there. You make sure you have that. So -4 meets 1 right here. It's -4 with 1. So that's the center. So we're talking about center. All right, so let's go to the side. So first, we have the center, which is A, B, and we found that the center is -4, 1. So already we know A is -4. We know B is equal to 1. So we have that. What we're going to do after that is now we want to know the scale factor. So the scale factor is what they call K just now, right? So the scale factor is K. And here it is that the scale factor is what changed. The scale factor is what changed one thing to the other. So what changed any side to its corresponding side? Like what changed this side to that side, or this side to that side, or this side to that side. So you want to zoom in on any pair. Just one pair works. So it means then I could just simply pick. So I'm going to use these Q, these. So I could check. This is 1 unit long from Q to Q prime. From Q to P is 1, but from Q to Q prime is 3. Scale factor is to take the image length and put it over the object length. So we're talking about putting 3 over 1. So the scale factor is 3. It's very simple. So that's what they want from the question. You do it. So let me just pause for a moment so that you can ask what you want to ask or so.
Sir, when you're finding the center of enlargement, you always go to the left side, or does it depend on like where the shape is?
The center of the enlargement it's not about left or right. It's about connecting 2 pairs of corresponding vertices. That's the idea. We don't know where it's going to be. So you notice that I highlighted them, blue with blue, R with R. You see them?
Yes.
So whatever you have, you highlight them. You draw a long line through them, and wherever the 2 lines cross, that's it. All right. So we don't know where it's gonna be, but I'll say this to you, and sometimes, all right, if you realize that so I'm gonna help you out to think like this. If you realize that the So this is the center. If you realize that the image and the object are on the same side, your scale factor is positive. But you see, if the image and the object are on two different sides of the center, when you work out your scale factor, put one negative there. It's going to be a negative. So in other words, then, if the center there so, and the image there so, and the object over here so, it's a negative scale factor. Just know that. Okay? So just giving you those little heads up. These are just in case. But like this, both of them are on the same side of the center. Both of them are to the right. Sometimes both of them are to the left. The key is if one on the left and one on the right, it's a negative that caused that. All right? Because negative split unity. So right now them unite. They're on the same side, or same page. All right. So as you can see, they asked those little questions, and that's how they do their thing. You just keep going, see what's coming up next. All right, we just keep going, keep going, keep going. Wait. Oh, okay. Does it look like when you scroll, you skip over? Oh, I thought it was blank, right? No. All right, there you go. So this one now says here, the graph below shows two straight lines, line 1, line 2. So this is coordinate geometry now, right? And it says they intercept the x and the y-axis at these numbers. So you get them. You get the coordinates where the intercept goes on. You were told that line 1 intercept the x and the y-axis at those. In other words, line 1 intersect this. This is 0, 2. The same line 1 right here. This is 4, 0. That's coordinate geometry right there. Now it says line 2 intercepts the x-axis, x and the y-axis at 1.5 and so on. So it's giving you what line 2 does as well. So it's telling you that here is 0, -3, and here is 1.50. They're telling you. So they're giving you those. All right, so you can always have them. Now, let's see what else that they want. They say, determine the equation of the line L1. If you're going to find the equation of a line, what you want is the gradient of that line and y-intercept. The thing is, we have already got the y-intercept. So the y-intercept, we call it C. So in this case, we got it. If you look back, they gave it to you. So the y-intercept for L1 is 2 right here. So they told us in the text as well as we're seeing it. So we know this is 2. So the only thing I need to do for L1 is I need to find the gradient, but I could use these to give me the gradient, 0, 2, and 4, 0. We can use those to get the gradient. So I'm gonna just set it up and you just see, go through. So remember, we have 0, 2, and we have 4, 0. So it's gonna be x1, y1, x2, y2. Just double check to make sure. 0, 2, 4, 0. So all you're gonna do is to find the gradient. Remember that gradient can be found by using y2 minus y1 over x2 minus x1. Set it up. y2, 0 minus 2 over 4 minus 0. So you have negative 2 over 4, which is negative 1/2. So your gradient, of which we call it m a lot of times, is negative 1/2. So if I have the gradient and I have the y-intercept, you can always just write the equation, because you don't have to work out the y-intercept because you got it from the question. The format is this. This plus doesn't mean that it must be a plus. It just means that the c value comes here. All right. This is your m value. So x and y will always be x and y. So y is equal to m value, which is negative 1/2, beside the x, and the positive 2 comes around here. This is the equation of that line. That's the equation of the line. All you need to do is to find the gradient and the y-intercept. So you could make a note that as long as you're going to find the equation of any line, what you really need is that. The gradient and the y-intercept. You got. All right. And you notice is a nice 3 marks question that. All right. So for this one, let's keep going. Give me a minute. All right, so we have with L1, right? All right, let's go for, so the question says, what is the gradient of L2? And then they're saying L1, the perpendicular. You know that when one, we already know, remember the idea, you know, remember the idea that when two lines are perpendicular, one gradient is the negative reciprocal of the other. So L1 gradient is going to help you to find L2 because they are perpendicular. So L1 gradient is negative 1/2. It means L2 gradient is the negative reciprocal of that. And when we say negative reciprocal, we're saying you're going to turn it upside down first. And if the first one was positive, the second one will be negative. If the first one was positive, was negative like this, the next one will be positive. So they are never the same sign, okay? So this is basically 2, positive 2. So it's coming from negative 1/2, it's going to be positive 2. That's the gradient for L2. No, that's all they wanted. What is the gradient of L2? That's all they wanted. So normally this might just be 1 mark because it's not a big deal. We expect you to know that when two lines are perpendicular, one gradient is the negative reciprocal of the other, which means the product of their gradient should give -1. if you were to multiply the two gradients every time they're perpendicular, the result will be -1. You have to make a note of that. We said it in class when we're handling our business. Here it is. We utilize that, right? Now, let's go. Number 5 now. It's always the statistics question coming always, all right? So I was going to be a statistic question coming up right here. Did I miss any question out from the next one? Or we're good? No? Okay, not really.
Yes, sir.
All right, good. Now, for the statistics here, we have a cumulative frequency curve. So a lot of times they'll give you the curve. So I'm going to take this to the other screen because if they give us the curve, obviously, we're going to be interpreting answers here. So we're going to have to go there to get the answers out. All right. So we're going to have to come to this screen where we can do something. Even though this graph is kind of, I hope it's not too lean because it kind of look lean. Oh, it look like it. All right. All right, we're good, we're good. Give me a minute, let me blow this up. All right. So let's go for the questions. So I'm gonna read. It says a group of 100 students estimate the mass of a seed. The cumulative frequency curve shows below. So again, the group of 100 students. Here it is that we have the cumulative frequency, and then we have the mass, right? So it says using the cumulative frequency curve, estimate the median. So using the cumulative frequency curve, estimate the median. I'm going to just write here like a reminder to us. The median is always 50. Median means middle. So it's 50% of the sample. So we're talking at our 50% mark. And remember, it is not raw data where I showed you how to find it, where your R is not in a table where you do that up down thing, and that's not it. This is just having the cumulative frequency curve. The median is 50%, and it is actually Q2. 50% is our second quartile, it's Q2. So what you're going to do is to find 50% of the total amount of things that you're dealing with. And the question did say it's 100. So 50% of 100 is luckily 50. So that's not the answer to the question, but it's going to help you to find it because 50% of 100 is 50 things. So you could see 50 is the marker. It's 1 mark for this because nothing to do. You're going to go find 50 on your graph on the cumulative side. And you're going to run a line until it touches the curve. Don't pass it. Stop it right there. Look, don't pass it and come here. So don't go right where it stops. The moment it touches it, you stop. All right? And when it touches it, what you want to do at that time is that you want to know. So I'm going to try to blow this up bigger for you. So it touches it right there, right there. So then you want to grab, you want to bring it down. So it touches it right there for me. You bring it up right here. You set it up like this. And then you're going to read off what is the score here. So you want to look between two consecutive blocks. Like if you try to check here, you realize that it's going up by 0.2. If you're not sure, you could, because between 1 and 2 is 1 unit. So you could say 1 unit was divided up into, look, 1, 2, 3, 4, 5 equal pieces. And then you could use your calculator to work it out. You'll get 0.2. It is telling you that every line is 0.2 being added. So that means we are at 3.2 right here, 3.2. So 3.2 grams would have been our median right there, straight up. Everybody good with our 3.2 right here? 3.2 right there. you pick up your 3.2, and that's going to be the response to the question. So you will say 3.2 gram. And I am saying they want to see this. They want to see you drawing these lines, okay? They want to see you drawing these lines here. They want to see it. You have to do it. It's a requirement. You draw the line. When it hit the graph, you bring it down. They want to see you doing that. It's a part of the whole assessment process. So that's that. You get that quickly, you get it, you're gone. You go to the next question. They want the upper quartile. The upper quartile refers to 75%. The upper quartile refers to 75% of the total. In this case, 75% is 75 over 100. The total was 100 again. So you can see, luckily, it is already 75 things or people, whatever you're dealing with. So you're going to go to your curve at the 75 mark. You're going to go where 75 is. That's where you're going. And you're going to find your 75. Make sure you find it. 75 is halfway between 70 and 80. So it's exactly halfway. Sometimes it is on a line. This time it's not. It's somewhere here. It's right. Let me just bring it. It's right there. Right in the dead center. The middle. So you bring this cross right here. Wherever it touches, you're going to bring it down. Okay? You're going to bring it down. So for me, it's not touching it. If you look at mine, it's not touching it on a line. And in these questions, everybody in CXC must get the same answer. So it's not like when you draw your graph and CXC looking for certain stuff. This time, they're looking for one answer. The entire Caribbean has to have the same answer. So you relax. Whenever they give you the graph, everybody should get the exact thing. Look where mine come. So mine now is not going to fall on any point 2. See there? That's where it is right now. So basically, we already established that 4.2, 4.4. So it's halfway between it's between 4.2 and 4.4. So I definitely know it is 4.3 exactly. This is 4.3 exactly, because it's between 4.2 and 4.4. All right, so that is the way you navigate. So I'm just trying to blow it up so you could see it right there. It's exactly halfway between that. So it is 4.3. All right, and then you just drop your answer. Whenever they give you these to interpret, honestly, it's like a giveaway. You're supposed to be nailing it. So this is a 4.3 gram. All right, for that. And you're done. Keep it moving. Keep it moving. Semi-interquartile range. In order to get this, one has to know what it is. Okay, what is the semi-interquartile range? You need to know interquartile range. But so interquartile range is Q3 minus Q1. Q3 was this. This is upper quartile. Q1, we haven't found that. We're going to have to go search for that, right? So this is interquartile range. Semi is half. So this is what we're doing. We have a number for this. We only need Q1. Q1 is 25% of the sample. So we're going to have to go to graph, go where 25 is, right here. And we're going to take it to see what number we have to work with. 25. Right there. And you bring it down. There it is. That's 2.3. So this is Q1. We needed this for the thing that we're doing. This is 2.3 grams. Yeah. So this one was Q3 right here. Q1, Q3, Q2, it's right here. But the interquartile range is Q1 and Q3. So you pick them up So what we have here is Q, I'm just writing this, Q3 was 4.3, Q1 was 2.3. So then it's going to be 4.3 minus 2.3, and then you divide that by 2. So it's 2 over 2, and we're going to get 1. So the semi-interquartile range is 1. All right? So you have that for your answer. And it's going to be 1 gram. Okay? The semi-interquartile range is 1 gram. So straight up, remember this is semi. If the question had said interquartile range, it's just Q3 minus Q2. Q1 should say. So this is the interquartile range, but because they use semi, we had to split it into 2. Remember that. So you want to, semi means half off, right? So there again, make sure you have those little stuff noted down so that in the event that you're asked, you're good to go.
Sir, one question. What if
Go
you,
ahead.
I was thinking, right? What if you made a mistake and put it like the Q1 before the Q3? It still you'd get it wrong?
What do you mean? Tell me what you mean.
Like you'd have the Q3 minus the Q1 divided by 2. So me say, what if you put the Q1 where the Q3 is and the Q3 where the Q1 is? You still get it wrong?
Yeah, because you would have get the wrong answer, right?
Yeah.
You wouldn't get 1. Would you? You'd have get -1.
Okay.
Nah. Q3 minus Q1, okay? All right. Now, this question says here that, hey, the number of students who estimate 2.8 grams or less. So you're going underneath that, not over, underneath that. That means wherever you find the answer, that's the answer. Okay, you're not going to do anything because this is up to 2.8. So you go on your graph, you're going to look for 2.8, and you bring it to where the students are. So we're going 2.8. 2.8. Let me see if I can blow this up for you. 2.8, we see it already look like. So 2.8 is you're going to take this line. Let me change. You're going to come. This is 2.8 next to 3. This is the line you're working with, 2.8. You take out your ruler, line it up nice. So I come here, line up mine here. So you take up your ruler, boom. You bring it up. You draw your line. You see it touch me right there. So boom. You look upon it, you say right. You stop it at the right place. And then you just take your time and you go across, you know? Draw it across like. See there? Nice little vibes. Not biggie, right? So, boom. So now you read it off. Now you say, oh, what going over here? So 32. So you look, 30, 32, 34, 36, 38, 40. So you have to know the scale. The scale is not like the other one. But this is easy scaling too. You could see 30, 40, you could just count. So that's 38. And they said less. That means you're going down. That means it's 38. It's not like you're going to take it from 100. This answer is 38. All right. So right here, this one is 38 students. And it's about students, 38 students, 1 mark. Talk to me, people. We're good. Tell me if we're not good.
Yes, sir.
Anybody else? We're good? All right. All right. All right. So here we're looking at this, right? And it says here, use a cumulative frequency curve, which is the one you just had, to complete this. So they leave out frequency. So remember now, they leave out frequency. Remember, everything have to add up to give 100 because a 100 student. And we had already discussed that. Then, when we were learning this, that the only way you're going to get these from your cumulative frequency, you're going to have to find what's going on. So it's like you're going to find the cumulative frequency for 4. You have this already. So whatever you get, you subtract it to get the number. Like you're going to find the cumulative frequency. So this is 20 here, for real. You're going to find the cumulative frequency here. And when you subtract it, you're going to tell you what is the frequency. Because based on how cumulative frequency is done, you keep adding up your frequency. So that means if you find two consecutive cumulative and subtract, it tell you what was the frequency at the last one. So we're going to go at 4 on the graph to see what number comes up. Okay? Let me show you what I meant. You go at 4 on the graph. All right. So if I go at 4 on the graph, I'm just going to go up to it. Where is my graph? Okay. Give me a minute. Let me just move it. 4 on my graph. 4. So I'm going to mark the graph. This is 4 on my graph here. So I'm going up with 4 on my graph to the graph right here. And then I go across. This is 68. Now, that's 68 on the cumulative frequency, not the frequency. So it's 68. So look at how you would have done it. Cumulative frequency, let me just put CF, is 68. So what was the frequency here? It's 48. So that 20 plus 48 gives 68 up to that point. Think about it. Cumulative frequency is the one that is added up. You understand? To give. So, and then you add frequency to give cumulative at that point. So at the point 4, the total of everything was 68. So if I know the one right on top of that, I subtract it and it helps me. So 48 missing. So now we have 48. Yes, sir. I'm going to find at 6 what was the cumulative frequency, and then I'm going to take 48 from it, because what we just did is to say 60 minus the 20. That's how we know that the frequency was 48. So if me ask if we do the cumulative frequency, think about it. You would have start off with 20, and then they said 20 plus 48 gives 68. That's what we're saying. That's how you do cumulative frequency. You keep adding up your frequency up to that point. Okay? So let's go for the other one. I'm going to go where 6 is. 6. And we're trying to find it. Okay, all right. My bad. Here is 6. I'm going up. And it looked like it is kind of in the middle. So we're going to have to look carefully. So we're going to go across to somewhere here. Looked like it's in the middle. So I'm going to double check it. 92, 94. I'm going to put it at 93. All right. But remember now, if I check it and I realize that my number isn't adding up, I'm going to pick a right number. But I'm seeing 93 when I go across. I'm seeing 93 because it kind of land in the center. So it's 93. So let us know. Go back to this. Let's go back to a table. So basically, this is saying the cumulative frequency up to 6 is 93. So I have to say 93 minus the 48. Sorry. So I could know. So let us see what we have. 93 minus 48. And am I saying the right thing? Is it 93?
Yes, sir. It is 93, sir.
Yeah. But hold on. No, man, I'm supposed to subtract 68.
Okay.
Yeah, we're supposed to subtract these two cumulative, right? So it's 68 to subtract it. My bad. Whatever you get. Can you subtract 2 cumulative frequency to give the frequency, okay? So 68. My bad.
25.
Yes, that sounds like it. 93 minus 68. 25. Right here is 25. So remember now, when you subtract 2 consecutive cumulative frequency, because remember this cumulative frequency would have been 20. That's why we subtract these. It's 20. All right. So, and again, if you keep adding up this now, make sure you get 100 now, and you know that everything is okay. If not, there would be a mistake. And yes, you can make error. You fix it. Make sure it fixes. You're supposed to get 100 when you add up your frequency. That's what we're saying. That's how you know that you never make a mistake. All right. Again, remember these little stuff. If CXC give you the cumulative frequency and asks you for frequency, it's your duty to find 2 consecutive cumulative frequencies, subtract them. And when you do that, you get the last frequency. The last one. You notice when we subtract these two, we get the 25 here. So when we subtract these two, we get the 40. We get it for the last up to that one, right? And so on and so on. So there it is. We have a completed table. Just trying to show you. Question says, a student is chosen at random. Find the probability that the student estimate the mass to be greater than 6 grams, to be greater than 6 grams. I believe we just use 6, right? We just use the 6, I believe. And 6 took us to 93. So we're not going to really redo this. It's already there. 6 is the marker. 6 took us to 93. Remember, 6 grams took us to 93. But remember the question, they did say greater. Greater. So you're trying to figure out now, when you come over here, so you say greater than mean that you need to go up. Greater is not less than that you're going down, you know. It's greater, so you're going up. So you want to know how much is between 93 to 100. Like you want to know, it's these people you're checking over this line. So you're going to say, but over this line is 100 minus 93, I just 7. Want to understand that. It's only 7 was greater than that. In other words, we're looking at the mass, you know, it's only 7 would have a mass of greater than 6. Everybody else would have a mass less than 6 or up to 6, right? So it's only 7. So now let's go to the question now, context. It says a student is chosen at random. Probability is a fraction. So 7 is not the answer. Let me see if it's 2 marks they're giving you for this. They're giving you 2 marks, right? So because it's 2 marks, if you put 7, it's 1 mark. If you put 100, it's 1 mark. If you put 7 over 100, then you get your 2 marks. Even if you say 7%, 2 marks. If you say 0.07 as a decimal, 2. Any one of these is correct because they are all representing the same thing. Okay? So this is okay. This is okay. Don't stress yourself. I'm just giving information so you understand context, right? Remember that your probability must be over the total. Whatever you have over the total that exists, and you're good. Let me just ease for a bit. Any questions? Statistics done, innit? Done. See there? As in, but I'm just saying, it's not like me know if them are going to send you this. You might have to draw it. You might have to do on Instagram. The same things that you do in class. But I'm just saying, here is what they sent a year. You should be able to just good to go. All right, number 6 is always measurement, like always. So be advised that number 5 is always statistics. So learn about your statistics. Go back on everything when we teach you. One of them have to come. Afi, when I ask. Afi, understand? Number 6, always measurement. What's the type of measurement coming? I don't know. A lot of times they will send solid geometry, like, you know, volume, capacity, and them thing there. Them sort of stuff where you use the prisms and so solid blocks, and that's surface area right here. So, and in the come nowhere else, all right, just say come. All right. So it says there that the radius of each of the rectangles here shown below, you said the circle it fit exactly. All right. So there it is. Then they said to us, we saw a question like this already. It says, we did. It says, show that the rectangle. Give that. All right. I'm doing, I don't remember. I think this is 2020. I think this is January 2020 paper. I think this is a January 2020 or something like that. Yeah. Because there was no, this is a pandemic year. There was no May, June. All right. So we want to prove that the area of the rectangle is that. Remember, if you're going to prove that the area of the rectangle, you need to start understanding what you're dealing with. What it is that you're dealing with here is circles that are pasted onto each other, which means you could utilize the diameter to help you to know the length and the width of the rectangle. So if this goes here, diameter is 14 because they told us the radius is 7. Diameter is 14. 14 again. And you'll use this until you reach the other side. So you know it's 14. So you will say 14 4 times. That's about 56, right? So 14 times 4 is about 56. That means the length is 56. And you're going to do the same thing. No, so this was actually 14 times 4. That's how you get the 56. But for the width, it's going to be 14 times 3. That's about 42. And this is going to be our width. So we are saying that we understand that. So the length and the width. So this is the width, while this was the length. Having that, then the area of the rectangle is to multiply the length times the width. So you're multiplying 56 times 42, and you expect to get what they get. If not, you could tell them that they are wrong, because what you did would have been perfect. So you get 2,352 square centimeters. So there it is that you would have gotten the idea. You would have proven what they said, because the aim is to show that the area of the rectangle is this. Let me stop there for a minute. Ask the questions as best as you want, people right here. All right. All right, let's keep going. Right, give me a second, guys. All right. Now let's look at the other question. So the other question says, hey, calculate the area of the shaded region. So you take a look at this. You want to find the background part, that gray area. So remember now, shaded regions, when it comes like this, is that they're gonna, every time you get a shaded region, you're gonna see two distinct shapes, or two distinct ideas that you can relate to, and you utilize them every time. In this context, the two distinct shapes we're looking at is circle and rectangle. We are gonna make sure that we understand that we have 12 circles here of the same size. So when you find one, you multiply it by 12 for the 12 of them. We have already known the area of the rectangle, so we're not going to rework something that we got. It's 2,352. We're going to find the area of those 12 circles, and imagine that you would have cut them out or punched them out. Imagine that you have a puncher that is the size of this, and you punch them out. Punching out is a form of subtracting when we're talking about math. Punching out is subtracting. So you're going to find the area of the circles and punch them out, and then the shaded region will be left, right? Everybody's supposed to punch out all with the puncher like this, and I try to line it up nice. We do it already at school, and when you're done, you see the little diamond-looking thing them hanging out. Do you understand? So basically, we're going to find the areas of the circles. So the basic idea, I'm going to put it at the top. It says calculate the area, the area of the shaded region. And I'll definitely say it is by calculating the area of the rectangle minus the area of the 12 circles. 12 at one. So let's go about finding the area of those 12 circles, okay? Now I'm going to find one circle first. So I'm going to write that the area of one circle, just one, is going to equal to pi r squared. They told us to use pi as this. We normally be obedient. 22 over 7 is pi times the radius, which is 7. We knew it was 7. We got it from them. pi r squared, 7 times 7. This is it, you know? So when you work this out, I believe I'm going to get 154. Yeah, it looks like 154. So when you multiply that, you're going to get 154, right? That's the area of 1. So for 12 circles, you will multiply this by 12. It's 12 of them, not 1. So it's going to be 154 times 12. And you're going to get 1,848 square centimeters. Now, this is what you're punching out. So the shaded region is to have your 2,352. You're going to punch out 1,848. And by punch, we mean subtract. Whatever you get will be correct. Doesn't matter what it is. As long as you do this, you are right there. This is one of the easiest measurement question that comes for a long time. You know, so I don't know if any more is attached to it. Waiting on anybody to comment, say anything. Let's go.
Everything is good.
Okay. So here they threw in a little trigonometry. So you can start mapping up your ideas. So you see they threw in a little trigonometry right here. Right? So let's see what we can do with it. Let's go again. It says the diagram below, not drawn to scale, shows this triangle, and you're looking at it. All right. All right, so we'll get everything in this triangle. It says state the type of triangle shown below. State the type of triangle shown below. State the type of triangle shown below.
Sir,
Anybody want to?
that isosceles?
Definitely. Definitely. See? Isosceles is same. Same. All right. Hold on. All right, so here it is. We are. 1 mark. I remember if all the angles are 60, it's called equilateral triangle. So you have equilateral. And if none of the angles are the same or the sides, it's called a scalene. Scalene. So we have 3 types of triangles, basically. This one, which is an isosceles. And then we have equilateral, so with isosceles, 2 angles are the same, 2 sides are the same. Equilateral, everything are the same, 60 degrees. Because if you take 180 divided by 3 equal things, you get 60. So you'll see that one and so on. So they do ask these questions to see how much you know from your 6th grade year. It says, determine the value of the angle P and M, not P and P, no politics here, P and M. So P and M. P and M. Now this is simple. So this is basic geometry. This is the 3rd angle. The total is 180. So if I should add these 2 and take it from 180, I'm going to get 180 minus 104. We're left with 76 up there. Everybody agree that we get 76 up there?
Yes,
Yes, sir.
All right. We may not go all the way because I might stop and then we can pick up on 8, 9, 10. So I'm going to go all the way to 7. I'm going to done 7. And then Tuesday we pick up at 8, 9, 10, and so on. All right? Because we know say time. So it says calculate the area. Anybody remember we do? Calculate the area of this. Yeah, man. I remember said, people remember said in trigonometry, if you have this angle here, and you have this side, and you have this side, CSEC love asking for the area. So in trigonometry, there is a formula called the sine formula. The area of any triangle that you have this type of information is to say half the A side times the side there times the sine of the angle. And I believe that's what they want to know if you got right now, because take a look at this, right? See? Take a look at what you have. They did give you this, right? Mn. So Mn is 12, which means if you understand isosceles, you automatically would have this here. Hello, people? Are we there? They're not going to tell you, you know. But remember that we said it's isosceles, so if you know, so we have it. We have it. So when we say have it, we mean information furnished diagram, information from text, from the clue here, furnish the diagram. So there it is. There it is. So basically then for this one, to find the area, look, 76 is what we just find, and 76 is the angle between. So let me show you what we have here. We have our triangle that's set like this, basically. This is 12.5. This is 12.5. This is 76. Can you find the area? Yes. So the area is going to equal to a half times 12.5 times 12.5 times the sine of 76. There you go. Put that on your calculator. Don't be afraid of that. Make sure your calculator is in degree. A half means 1 divided by 2 or 0.5. It's up to you, right? Times 12.5 times 12.5 times the sine of 76. Press equal. You don't have to do any form of stuff. No matter feel like, yeah, you don't have to do any form of thing. This is the setup. This is working out for CXC. Answer next, 75.8, and it's centimeters you're dealing with. Boom, done. So this is what we mean when we said show working. We mean show us what you're about to do. Then the calculator do it for you. Anybody with a question here? Are we good? Talk to me. Good? We good? All right. We are good. All right. Let me see if so it's done. See, 9 marks done. All the questions in section 1 from 1 to 7 is 9 marks each. Let me check it up quickly. So 9 marks, that's 63. I suppose to 1 to 7. Oh, let me feel like a 10 marks for the next one. Me feel like a 10 for this. 2, 4, 6, 8. Yeah, 10 for that. So okay. So all right. So let me check it up quick. The first 6 is 9. 6 times 9, and then 10. All right. And then you have 3, 4, 5. Seems like a 999, and then the one that 10. Let me look at the next one. It's all in the then normally put it at the bottom. If you know above. 9 again. Yeah, see that is 9, 9, 9, 9, 9, and then this is 10, and then the others should be 15, 15, 15, 45. Anyways, so let's get it. Again, this is compulsory. Like everything we do just so far is concept compulsory. And when I say concept compulsory, percentage upon your paper, fraction upon your paper, rounding off upon your paper, algebra, factorization, solving algebra, them man, everything we do, it depends on it. I'm not gonna say the question are gonna look exactly the same, but the concept is on it. All right. This is on it. All right. So you read, they don't want you to draw anything here. So basically, I'm going to go straight to the thing. They want you to fill out the missing spots. You fill out the missing spots. Well, remember, we talk about this, where first you look. You could look, you could see it a flow. That means we can guess this. We can guess this based, I don't want to say guess. I can predict this based on the fact that we have 1, 2, 3, 4, 5 going down in order. And so we can predict what's coming next. So we're going to put it in and then we come. Everybody could see what's going on here. You're going by 12, you're going by 12. So this is 60. Okay, you're adding 12. Everybody could see we're adding 12. You could see we're adding 12. We're adding 12. You know? This one, you're adding 12 as well. Yeah, you're adding 12 too. Talk to me. Talk to me. We're adding 12. So we have a nice 12 by the one. And we spoke about how you do that. So I'm saying that you could fill out this. That means this one is 61, right? So you fill out those, right? So you get 2 free marks. But you see, for the other marks now, so normally they warm you up into it. They warm you up into it for real. So they warm you up into it right here. So you could get those 2 and feel nice. Then they're going to skip. See that? I'm going to tell us that we skip now. So don't add any more. Like that, they're going to fall in trouble. So you want to predict what's here first. Let's figure out this, and then we use, so we're going to figure out the nth, and then we use them to work on the other things. Remember I said to you, if CXC make the mistake, of which they're always going to do it, and give you a common difference, that means your pattern start with 12n, and you're going to check it to know, do you need to add or subtract? You understand? Because sometimes you add, sometimes you subtract, sometimes you do nothing. So let us see, 12n, so you said 12 times n. You just do 2 of them, you know, just check 2 of them. And if you connect, 2 of them connect, you're good. Normally 1 connect to, you know, but me just make sure I tell you, so try 2. So 12 times 1 is 12. 12 times 2 is 24. That means I don't need to add anything to this. I want you to understand, you know, just add or subtract for no reason. You add when you try reach a bigger number, and you subtract if you wanted to go down to another number. But you leave it if you don't have to add or subtract. So in this case, you never had to add or subtract. 12n work for this column for S. We're good. Now let's go to the next one. Everybody see the point I'm making? No biggie with no stress, nothing. So right here, this is 12n. We're certain based on the pattern. But we're going to check if it works, or we're going to have to add or subtract to find the number next door. So you're going to do the same thing. We're dealing with 12n, so this is 12 times 1. And you said 12 times 1 is 12, but what do I do to get 13? Can somebody tell me?
Add
12
1.
times add 1. Right, that means it's add 1. So we're going to work it now and see if it works. So we're going to go 12 times 2 and then add 1 and see if it works. 12 2s, 24. Plus 1, 25. It works.
25.
So it works. So that means, look at the bottom now. Look what we have in the nth column. One of them is 12n, the other one is 12n plus 1 more. And it does make sense. Because look at 60 and 61. Everybody see where I go on? 60, 61.
Yes,
right
sir.
now we know what this is. Anybody want to guess this based on what them see now? Talk to me.
157.
Exactly. I won't even do it yet. This is 157, but I'm going to work it the long way, but I'm going to see. Say, based on how you roll, you can accept. You see what I go on? You understand? So, question now, let's find this n. If I want to find this n, I'm going to take the master for the S column and relate it to the 56, the 156. And it's going to tell me what n is. So, in other words, 12n equal 156, you know? Yeah, man. So, dividing both sides by 12, I'm going to tell me what n is. 12 or 13. N at 13. You ever say 12 or 13? N is 13. Yeah. And then if you want to say 12 times 13 plus 1, you're going to see the 157 come up. Right, yes. So now how would you move from 13 go? You're going to say 12 times 13, that's 156, plus 1, that's 157. See there? Perfect mark. 6 mark gone down your grade already. Talk to me, the people. We're good?
Yes, sir.
We're good. All right, we're good. Make we keep rolling like a dice now. Because we're going to cut it after this. And then, as I said, Tuesday. Oh, so I'm telling you, so I'm going to do this Tuesday night. I'm going to do this Thursday again. Understand? Thursday we might go longer though. Thursday we might just a bounce until we drop asleep in the night. So, we could go. B. The sum of the dots in 2 consecutive figures are recorded. It said the information show the 3 pairs of consecutive points. All right, so we have that. We have that. So it says determine the total number of dots in figure 8 and 7. Take a look. Look again, you know, look what they're saying. All right, let me go back to the table. 13 plus 25, where is it? All right, look. 30, hold on. Okay. Figure 1,
Sir,
figure
if
2.
you look, there's a pattern where you take off 1 to get the answer.
Oh, which one?
Sir?
Talk to me,
Alright,
may I listen to you?
look at the 13 and the 25, right? In figure
Yeah,
1
man.
and 2. Then when you
Hey,
look
I'ma
at
go.
figure 2, you see 25 there, and that same 38 here, they take off 1, you have 37, leave the 62. When you add it, you get 62 there. So it's like a pattern there where you could get that answer.
Well, and as I say, when you look, whatever you see, make it work for you. Like, whatever you see, whatever you pick up, roll with it. What happened to the screen? Yeah, man, roll with it. So you just read, but most time they'll tell you, look what them say. Them say the sum of 2 dots. So what is that? Look up here, say, I gotta say dot. See the dot them here? The sum of 2, right here, so that a dot. So it's like, then we tell you, and look at this. These are sticks. So these are the number of sticks, and these are the number of dots. Because remember, at this them are pre. Them little thing, they may stick, stick. And those are the dots. So that them are talk about same way. So them are say now the number of dots in 2 consecutive figure. So if you line up 2 of them, boom, boom, underneath, as you say, are recorded. Right? So you notice the 25, the 13 and the 25 consecutive, 25, 37, and so on. So they must show you, like if you look, they must show you, say, we are at this and this, then we're going to add this and this, then we're going to add this and this, then they must say that one, all right? So they must show you that. Them just show you something where kind of there. And then they're saying, now, this information works for the first 3 consecutive turns, blah, 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 right? So them show you 13 and 25, this and that. And I must show you all the way you have right there. So they must have determined the total for 7 and 8. So you're going to need to find 7 or 8. Is 7 or 8 in the table? If 7 or 8 in the table, you work it out. Because remember, say you have a pattern to find that, you know. Look. You see 7 or 8, you realize 7 or 8 in the day, so right, people? But what you have a pattern to find that. What a pattern to find that, people? Come on, man. What a pattern to find? Now, this is a pattern to deal with that. Talk to me, people. Huh? So you can find 7 and 8 and you add it. Because remember, in the dead, look. 7 or 8 is not here. But can you find it? Yes, because 12n plus 1 give you it. So I'm just saying, if figure 7 is to say, okay, the number of dots, we under the dot column, it's 12n plus 1. 12 times 7 plus 1. 84 plus 1. Hold on, why this look like it now? Right. Sorry, this is 85. So that is the 7th. The dots for the 7th figure. Now for the 8, for figure 8, the dots for figure 8, same pattern because we're under the dot column, 12n plus 1. This is what give you everything under D. So when you don't know, you plug in, if you want to pick the 100th figure, 12 times 100 plus 1. You understand? And you work out this. This I give like 96 plus 1. This is about 97. And then now you add it up and you tell them now. Add up, and you tell them the total, right? So figure 7 plus 8 is equal to 85 plus 97. Whatever you get, you are right. I'm just saying, bigger than that. So them just as I can go find this and add them up for yourself. That's what they're saying. You're good to go talk to me. And the moment you find one, you could have just put 12 pan if you get the next one, right?
Yeah,
85 plus 12.
say it's like a pattern.
Yeah, man, it did it. Because remember, I said we already knew that it is 12. That's how we get the 12n. Because if the consecutive is 12 between them, that's all. Yeah? All right. So you have that. One more there, you know. See, 2 marks gone. Look at this one. This is the little algebra that I'm going to trick you with. Them said you must add up figure n and n plus 1. So here the deal. You want to add up figure n. So you know figure n is this. This is figure n. Jeez, I'm going to write this so ugly. Figure n was 12n. All right? So figure n, 12n. So you want to add up figure n, one more 12. So you want to figure n and figure n plus 1. So now, n plus 1. But remember now, no? Remember now, it's the number of dots we are dealing with. Make sense? So figure n for the dots at this, because the dots we are dealing with. Right? Dots. For dots, we're under the D column. 12n plus 1 is for the dots. That's for n. Let me show you what I mean. Let me show you what I mean. N for the dots is this. Don't be mistaken. N for the dots is this. Don't think it's 12n and gone. No, that's for S. For dots, the n for dots is 12n plus 1. That is for n. But remember now, that's 1. And you want to add this to this one. Remember now, you're going to put the thing right there. So make we put it right there and you see what we mean. All right? So now, so that's we're having this. So now we're going to do, this is for n. So let us do n plus 1 right here. I'm just calling this figure. I'm just put it like this. Figure n plus 1. You're going to have 12 n plus 1 plus 1. So I'm going to relax now. Let me try to help you. Remember, it's 12n plus 1 you're working with, right? But they have a figure called n plus 1, if you confuse you. It's like doing functions where you're going to put n plus 1 where n is, we had to interject it there. But you have to remember now a binomial. So it's going to be 12n. You have to distribute it. Like I said, this day you can't go around this because of n plus 1. So it's 12n plus 12 this, Then the one outside long time. So 12n plus 12. Then that one was already outside. So be careful. I think what about people get this wrong? Because remember this question, this is the question they always make me wrong. What about people get it wrong? So when you're going to add them, you're going to add this. Then you're going to add this. But this is, can everybody agree that this is 13? Talk to me.
Yes, sir.
So you're going to add this. So you know what you're going to get? 24n plus 14. That's the answer. Because you're adding them. so this is figure n. It's just that figure n has a plus 1 in it. And people, and then this part with a little algebra. So every now and then put, these are the reasoning part when R, this part come under R. Because every question, K for knowledge, that is where they do the guessing one up at top, the easy one, that's a knowledge. You see the rest of them are C for comprehension, you understand. And you see right now, so every time I used to them put your R. The R.
Sir, I'm not understand the part then.
Yeah, because you're afraid of algebra. Yeah.
No, it no matter of afraid.
Go on now.
Sir, oh you get the 24 in there.
Oh, you were adding, man. You're actually not look then. What is?
So that's a 12n, yes.
What is?
Oh,
I mean, I say
and then you have that 12 plus the one, that's where you get the 13.
You mean from over here, so? Because when we distributed this inside, it become 12. But there was a one long time around here, so it become 13. Yeah. As me say, this part people are getting wrong because you're substituting it in this. The figure, normally if me say the figure is 8, you just put 8 here, so. If me say 9, you put 9 right there, so. So you say if we tell us the figure name n plus 1, do the function where you do the same thing. Remember when me tell you, say, sometimes I might give you a weird function when you're doing functions. Yep. So it's the same thing. So right here, n plus 1 is the new thing. Plus 1 is still out there. This is the new thing. It could have been an 8, it could have been a 7, but they said it's n plus 1. Put it in there. What you would know algebraically, this is a binomial. So 12 times n, 12n. 12 times 1 is 12. And then there's a 1 out there already. We're going to turn it into 13. And you keep working. So you just have to do your thing. I eat that, we're going to pause because we're there for 2.5 hours, basically. All right. So regular class tomorrow, linear programming. You need to do something for yourself because it probably come. I don't know if it's going to come because they have multiple choices to pick from. Yeah, but it's under there. Get me? If you look at, I'm trying to do some quick, probably maybe the 2 and 3. Like I'm trying to do some topics like I'm telling what comes at number, this is what comes. I started doing that. If you look at number 8 has the most. Like they have the most things to pick for number 8. All right. So they have a lot of things to pick from number 8. So you can, if your teacher don't cover all of them, you could go there and what you do is not at number 8. Because right now we have one thing we're gonna do yet. And it depends this. It look like this. I'm planning to do it Wednesday night. We don't know. I'm gonna see it. This is the only thing we're not see it, none at all. See, can come at number 8. So this is what I plan to do Wednesday. You can do in a 2 hour, a speed and time and them thing. So this can come at number 8. So we say number 8. Everybody we do this. This is completing the square. We do those, but they don't have to send it. You get what I mean? We do these, they don't have to send it. They have option. Because them could have put different quadratic, yes, so. Them could have put linear programming right, yes, so. But they decided to put this here, at the time, and then put this here, and then put this. And they never have to put none of this. They could have put 3 different things. So, but as I said, we only have this left that we have never seen to go there. We do that Wednesday. You done the syllabus Wednesday. We couldn't done it before, to be honest, unless we have to go super fast. But anyways, so far, in terms of topic, we can tell you, say, we're exposed to 99.999999 except the one something. That's the only thing. And I said, oh, construction. So 90, yeah, and construction must come. And if you come, I like 2 marks, so I don't even worry about it. Understand? So construction can come, like when we say can come, it's not a full question. You can come for 2 or 3 marks at number 3 only. Can't come nowhere else. So that's all or nothing. If you can't construct, ignore that. Understand? But enough question upon the paper where you're going to be exposed to every single thing already, to be honest. Because if I just randomly pick a paper, I'm going to show you again. Let me show you what I mean. If I randomly go so, we just attack because we soon let it go. If you randomly pick, send me just Google CSEC Maths Tutor, and we say, all right, log in, and you just pull a paper, like randomly, these are papers. And me just pull, send me just click on a paper. This is paper 3. So we just click on a paper. Boom. All right, you click on a paper. If you click on a paper, 9 out of 10, when you open it, you do it right, you do it in a class. Like we can just open it, go up at number 1, just random paper. Okay, this is how I come at number 1. Basically, are them thing. And your calculator and you them there. Take your time. These are still calculator. This put them on your calculator little, and you work them down. We talk about that. Percentage. Them I come. But you touch number 2, algebra. Algebra. We just do those. Same thing. Yeah, we just do these. This is variation. We didn't do that, but variation. Come here and I said it. You can get variation at number 2. That's it. Then you go right into transformation. Can come here and transformation. Right, yes. Then I ask about transformation. That's the same thing. Number 4, But at number 3, now them have to send transformation. They always send it with something else or just straight transformation. So if them all go hard like this, they give you all 4 transformation here. All of them were right here. So then I'm about to put nothing else with it. But when I'm going to put something else, I'm going to drop off 2 and then give something else. You understand? And they can't give construction for 2 marks, probably can't come. Because it come under geometry. See number 4 function thing here, so we do them there. Coordinate geometry. You do that. You do that. Keep rolling. Statistics. Fill out midpoint, blah, 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 blah. Whatever them are ask your statistics. And then by you done your statistics, see them at cumulative frequency curve, you're gone in these measurement, where the solids, and then by you go through pattern number 7. And then by you go through number 8, come see the big topic, your algebra, relation, function, and graph, then you see linear programming right here. So boom, this may talk about. So that they can put the linear programming right here. So I'm listening, you can talk, but that's a review show.
You have to carry the paper, or does CXC provide
CXC
paper?
have them thing. No, you don't need, you only need what I post in the group. I sent what you need to have for the exam. CXC thing well organized. The graph is made in the big, nice, pretty graph. Big and pretty. You see, when you see on screen, it you'll get one black and white graph, but it's nice. Linear programming can come at number 8, as you could see. So I didn't provide you a graph. So that's still linear programming that. That's all. So hold on. Linear programming alone there. So hold on. Something else missing. Okay. That's it. 3 marks. 4. Unequal. Okay. Because then go add this one. They ask if you search shade and do everything. Okay. 12 marks. Linear programming they said at the time. That's what I'm saying. What we have to do it. Circle theorem is always right here. Followed by bearings or so. Right here. Think about it now. We do everything already in a class, you know. To be honest, you know. I don't see one thing where we do it, you know, but one scroll. So bearings, matrices. All right. The only thing is now, them can turn your matrices in a rotation and then think the transformation. So this year, for the matrices, instead of give you a regular matrices to work out, then give you transformation, because transformation in a matrix, as I'm telling you, say transformation in a matrix, so then can put it yes, so if them want, if they don't feel like give matrices, but then can do nothing else. Then can put it yes, so, but then have to give a vector question after that, like AFI. You understand? So they're going to go in a vector, right? Yes, so. You understand? So look here, so now. So them ask about singular matrix, right? Yes, so. Them can give you transformation. They can make a rotate sitting, do sitting here, so. As well as they can give regular matrices. I like when them send you regular matrices, because people kind of like it easier. And then the vector come where they might give the same vector them what we talk about like this. And this is a random paper. Like me just click on a random paper. Done. So we done this syllabus, people. I me just I got hard because I hate not doing every single thing. But we are actually done. And when we say we done, we mean we done, but we need to touch when we say we got touch, so that we are more than prepared for the exam. So let me just say this to you now. Paper 1 is 3 weeks from now. So that's why I'm not touch it yet. Me have all of the multiple choice question them and the ways we do it. So normally when I'm done with my class, at 60 out of 60 when I get for multiple choice. So don't worry about that. Me have that set up, plus me have tests on the multiple choice, so now go click on and see if we really I get it right. Me have them there put on already. So we're good. Me just want to focus on the paper 2. So please spend some time and work, even though I say it from a long time. Spend some time and work. Me just a try help you now closer to the exam by working, but we don't feel work long time. Take care of yourself. Class tomorrow, and then we work Tuesday, and then class, and then we work Thursday. I hate that. Anything? Look more.
Same to you. Thank you, sir. Appreciate this
Sir.
class.
All right. Cool.